Hey guys, this is Mainak, your Silver. So today we'll do pushover analysis in Etabs. So since pushover analysis doesn't design the building actually, so we are going to design the building using response spectrum and then perform the pushover analysis real quick. So let's get started. And if you like my effort, make sure you drop a like. It really encourages me to make more videos. Okay. So first of all, I'll just create a new model and use the default settings here. Okay. And number of grids lines, or just keep everything default. Let me just keep everything 2. Okay, and then replace the bottom story height will be 1.9 meter. Number of stories, let's keep this as 3. Keep it small, which is pushover analysis requires a lot of time, so that's why keep it small. I made a smaller model. Okay, so just click on OK. So we'll just quickly go to the definition, material properties. Here, this one, we'll just modify the properties here. So it will be M25 concrete, and then just change this to 25, and the remaining things can remain the same. And just click on OK. And then for the steel, this is the rebar. So for the rebar, we just modify this and do this as FP 550. This is the rebar, and for the rebar, just make this as 550, and then click on OK, and then click on OK. So the rebar and concrete has been defined. Just click on OK, and again we'll check whether the material properties which you have provided are correct or not. Appearing or not. So just check this frame sections. We'll just go with this concrete column, and we'll just modify this concrete column and do this C, maybe 400 was 400 and 25, and just change the size here, 400 into 400, and you can modify the rebars. If you have it already there, column is already there, so no problems. Just click on OK, and complete beam, just modify this and just do this P, maybe 300 cross 500 and 25 with 300 and 500, and this is already OK, so no problems. OK, and then click on OK. Again we'll see whether section properties for the frame section are defined or not. It's defined, so it's fine. Double check everything, it's better. So section properties for the slab sections, slab 1, we'll just edit this. So the slab 1, instead of 1 is 150 mm, and this 150 mm is there, and it will be slab and 150 mm. So click on OK, click on OK. Okay. So then we define section properties we have defined. Then we will define our diagrams. So we have 2 floors, so add another diagram, rigid. One is already there, so 2 diagrams for 2 floors, it's okay. And then we will define our for the functions, we will define our mass source. So we'll just modify this particular mass source, and I think before defining mass source also we need to define the loads, so it will be better. So we'll just go to load patterns. Here dead load is there. In this dead load we will put the self weight, and another dead load will take in which we will not put the self weight, so we will put 0 here. So I'll just go here and do other dead. So in this dead load we will provide all the floor finish load, load of the walls, etc. So just add new load, and there will be as MX seismic load. By the way, a detailed video on the source spectrum in the previous video I've made, you can check that out. So total lateral load, we'll just add the highest code, latest one which we have here, add new load, and seismic in the y direction, and add new load. So we'll just modify and correct the things, modify lateral load, x direction. So it's this. For zone 5 it is 0.036 important factor will take as 1, and this is okay. And this also you can calculate and put it here. So using this formula we'll just do this. So this is basically G plus 2 building, so the height is 6 meters, so it will be 0.09 into 6 and divided by root t. So root t is same for both the sides, so it's 2 meters. So it will be, the value will come as 0.38 for both the directions here. So just flag 0.38 and click on OK. And here also modify lateral load 0.38, and here this is for y, so it will be y only, and click on OK. This is for zone 5, all the other factors are taken, so click on OK. So this is when defined, and then we can define the mass source, modify the mass source, element self mass specified load patterns, dead load will take, and the other dead load will take, and then the live load, a percentage of that as per the table 10 of ASCE 1893.25% will be added here for the residential building, and click on OK. Mass source have been defined here. So and then we will define the function here, response spectrum function, and we will define the response spectrum function as per the ASCE code for the design ASCE 1893-2002, and add new function here, and function 1 damping ratio, this is for zone 5, and this is the soft soil, and we'll just click on OK, and function is added. We'll just delete this function because function 1 has been added. So this will be our response spectrum function. Click on OK and click on define. The functions have been defined, mass source have been defined, and then the p delta options, we'll just do this non-iterative based on mass, since we have already defined the mass source. And then we have the model cases, so we'll just modify the model case here. So this model case model, and the value preferably it will take as eigen, and this already we have defined as per. So maximum number of modes here is 6, 3 if you consider 2 translational, and 3 degree of freedom in each flow. So 12 will be, should be okay here for the maximum number of modes. So we'll get OK data. So just click on OK, and OK. Mode has been defined. Then we go to load patterns. Load patterns already define load cases. So in this load cases, you can see dead load, live load, other dead load, and the seismic load are there. We'll add our response spectrum load. So add new case, and this will be let's call it RS. So we can add 2 response spectrum, RSX and RSY. So this is already there. Add, and then it will be our it's based on acceleration. So the direction will be UX, UI, and UZ. Okay, so sorry, we have to do this as response spectrum. Okay, then it will be based on acceleration. U1 is in the x direction, and U2 is in the y direction, and here we should take the function which you have defined. So that is the response spectrum function 1. And now there is a scale factor. So scale factor formula, scale factor equals to Ig by 2R. So you can see it is I is in photosspectra, which is 1, 1.2 or 1.5, and G, this unit is in mm per second square. So you can check from here also in this question mark, this is mm per second square, in the acceleration is mm per second square. So the G is in the mm per second square. So and R is response direction factor, which is 5 for SMRF. So if you just do input factor for this building, 1 into G, that is 9810, and it is divided by 2 into R. So 2 into R means 2 into 5, that is 10. So it will be as 981. The scale factor here, it will be 981, and this is in the x direction, and just click on OK, and another one will add new case, and this will be RSY, and this will be in this response spectrum, and click on add, and this will be U2, that is in the y direction, and the scale factor which we previously calculated 981, just add here and click on OK. So response spectrum has been added, and then just click on OK, and then I can define the load combos. So just define the load combos, add default design combos for complete frame design, convert to editable, OK and OK. So these combos have been defined here, and yeah, we forgot to just assign the supports here. So the page story, just select and assign the supports, okay, and do the modeling also. So first of all, we'll just go to the plinth level, that is the story 1, and here we'll just draw the columns here. Let's do this very quickly. So just click here, put it on a quick draw columns. So just draw it here, and before drawing, make sure you just have taken the right property. So our case it is C400 to 400. So columns are prepared, and then we have these quick draw beams. We'll take the property here and take the property P300 to 500. Just draw the beam here, and we'll what we'll do, we'll just go here to this particular, we'll just set this 3D drawing and 3D and click on display, and simply just go to view and set 3D view, and we'll just do this 90 for selection only, 0 and 0. Okay, so just click on escape and we'll select this like this, the beams and columns, and then we'll do here edit, replicate, and by story, the story 2, apply, and we'll go to story 2, move up to story 2, to the base, story 1 and story 2, and assign the slab. So for the slab, let's have here the option of quick draw floor, and just select this as slab 150 mm and assign the slab here, and after that we can go back to the front view, click on escape, select this and go to edit, and OK, select this and select this also, and then go to edit, go to replicate and story 3, apply. So once this application is done, we can simply go to the base story here, select this and assign joint restraints, select on the fixed and OK. So then we just hover over it a little bit, you can see the sign has been changed from hinge to fixed. So once this has been done, and just you can see in the 3D view also, 3D, click on 3D for the default 3D view, and click on this extrude option. You can see it easily. So I think the topmost floor didn't copy the slab, so we'll just assign the slab here, no problem, and slab 150, click on this, we will assign. So this has been assigned, supports have been done. So let's put the loads, select the slabs. You can also use the select option, okay, for that also. Select by object, select and select the slabs. So there are only two slabs selected like this, and now we'll go to assign shell loads, uniform loads, dead, and this will be in the gravity direction for the floor finish 0.5, apply and OK, and then we'll select this, I'll select this again now, then and just assign. So we'll go to assign and shell loads, uniform, and this time for the live load. So I should have put the previous load in 0.5 in other dead load. So I'll just press Ctrl Z until this disappears, and then I'll select the shell again. Just simply go to select, and we'll go to select by object type. Okay, select here object type, and then we'll go to floors, select and close, and after that we'll go to assign shell loads and uniform loads, and this will go other dead load 0.5, gravity, apply and OK. So once this is done, again we'll go to select, get previous selection, and then assign shell loads. This time for the live load we'll do live load, and this will be 2 for residential, apply and OK. Shell loads have been applied, and then we'll go for the wall load. So select all the beams. So we'll go to select, and by object type beams, select, close. Now we'll go to assign frame and frame loads and distributed for that other dead load, and it will be 0, let's go 7. Okay, just click on apply and click on OK. So this has been applied. Dead load and live load has been applied. Self load it will take automatically. Earthquake load also it will take automatically. So simply, first of all, in the analyze option, you can see check model and just select all and then click on OK. So if there is any error in the model, it will show. So model doesn't have any error. So then you can just go to analyze and simply you can just go to load, select set load cases to run. So all the load cases are running here. So let's just run the model now, and you have to save obviously the model before running the model. You save the model and then it will run. So the model has been designed here. So we can just check the design here, or simply just a concrete frame design. If you click on it, the concrete frame will be designed. So you can see that the AST is also showing the concrete frame has been designed here. So again, you can just go to design, concrete frame design, and just verify all members passed. So all members have passed the design check. So nothing is failing. Now we can start the pushover analysis. Okay. So all these steps were before just to ensure that our model which we are working on is passing. So now we can go for the pushover analysis. So the first thing which you need to go, so in define our load cases. So you can see these are the load cases which we have. So first of all, for the dead load, we have to you see this is the load type static. So we'll just modify this, and this will be non-linear static. So we have to change this into non-linear static. Okay, so just go and this one also other type modify. So the two types of dead load which we apply, two parts, sorry, and just change this to non-linear static and then click on OK. So this has been changed to non-linear static. Now we can add new case. So add new case, we will just push over. So PO X will do pushover analysis in the X direction, and this will be non-linear static, and then we will just select this option non-linear case. It will start from dead. So to start from dead and then we will go to other dead. Okay, so like this it will do, and after that we'll just click on add, and this will do acceleration in the X direction and a scale factor of 1, and this is the case. And load application we'll see. So here these are the loads here. So we'll just go with displacement control, and let's suppose take a load of up to displacement of 300. We'll just check the things up to displacement of 300. So you can do this and click on OK, and in this result speed we'll just do multiple states and just click on OK. So you can do like this. So just click on OK, and this one you can copy. So we'll just add copy of case so that you don't have to change much. So it will PQY, right? PQY, and this only will just change in the Y direction, and nothing you need to change. Just click on OK. So this is done here. Now just click on OK. So results will modify, obviously it will be done. So another thing we need to check, it is the, let's see, the mass source, and modify mass source. This is already have done. So now we need to apply hinges. So we apply the hinges on beams and columns just for the time history method. So we'll first of all let's apply to the beams. So before that, I think we forgot to assign the diaphragm, so we'll just redo it. So story 3, we'll just select the story 3 here, like this, and then go to assign between joints, right? So let's first unlock the design. Okay, and then select this, and then by the way, I've just turned off the slab like this. You just select this, and here set these the options. If you just turn on the floor, then the slab will can just apply, and here slab will be on, and you can just apply, slab will be off. So it's like this. So selected this, and click on sign, joint, and this diaphragms, and go D1 and apply. Okay, and go to define diaphragms, click on another diaphragm, add new diaphragm, D2, and we'll just assign it a level below. Okay, select and assign joint diaphragms. Okay, D1 is not being collected, so just define diaphragms, add new diaphragm, D2, okay, and then assign joint diaphragms, D2, apply, and okay. Okay, so diaphragm has been defined. So now we need to do the and apply the hinge. So for applying the hinge, just let's use the 3D view, and you select by object type, and then we'll go with beams, select, and then close. Beams have been selected. Now we'll go to assign frame, and hinges, it is turned off. So just move this a little bit like this using the mouse button. You can again try assign frame hinges. So this is a glitch. If you move this, then it will option appears. Now we'll create hinge at 10% and 90%, that is at 0.10. okay, and add, and here we'll select the table. Since there is no Indian code in this, we'll select the table of ASCE 413. okay, and the degree of freedom will be the bottom one, that is the M3, and it is for the, you select this beams, that is the concrete beams. So concrete beams, fracture items, you have to select, and in the case combo we'll select here PQX, so this pushover analysis in the, so PQX, that pushover analysis in the X direction, and click on here OK. So 0.1 has been added. Similarly, we'll just add another same thing, and it will be same. This will be also the same, and this will be okay, this will be PQX only, but this multiplier, you should modify this. Now you can just delete this again, add it again. Okay, just cancel this. Okay, now add 0.9. okay, 0.9, and then click on add. Now this is same, this is same, and this is also PQX, and click on OK. So PQX 0.9 and 0.1. okay, and now again we'll just do 0.1, and this will be PQY, and add, and 0.9, click on add. Now PQY, okay. So for the beams, this is done, and now click on OK. So hinges has been created. You can see these two hinges, at one at the near end, the far end. So at 0.1 and 0.9 hinges has been created. So now let's select all the columns. So for selecting all the columns, go to select by object type, and this time we'll select columns and select close. So columns have been selected. So assign frame hinges, and now again we'll just do 0.1, click on add, and here this will be concrete columns. Use this property P2, M2, M3. Load case is, it will be, first of one will be PQX. Click on OK, and then 0.9, click on add, and click on OK, and then 0.1, add, and this will be PQY. Click on OK, and then there will be 0.9. Click on add complete columns, click on OK. So these properties are added, and then click on OK. So now hinges has been created in the columns as well. So now another thing we can do, we can go to your assign here, frame, and we have to select all the beams and columns first. So go to select object type, and select the beams and columns. Control and select both. Both are selected. Close it, and then we'll go to assign frame, and then hinge over, right? We want, so just hover over your mouse with the mouse wheel button a little bit to just get rid of the bug, and then we'll go to assign, and then we'll go to hinge override. So if you're using Etabs 17, 18, 19 or any other version, this bug is not there, but if you're using Etabs 16, this bug is there. So here, this is how you can fix this bug. So hinge overrides and auto subdivide, just this at hinge, you can just do 0.1, okay, relative length of frame at hinge, since we are doing it 10%, so you can do this at 0.1, and then click on OK. So this you can do, and then you can go to analyze and check model first, okay, and select all and check the model. So check it properly, check model and select all, and then check. Okay, yeah, no warning is there. Then we'll go to analyze, and we will go to set load cases to run. So this thing, just do not run. Dead you need to run, since all the non-linear will run. Okay, do not run. Other dead, non-linear will run this. SLX do not run. SLY do not run. Response spectra also do not run now. This also do not run. PQX and PQY you need to run. Okay, so this you need to do, and just click on OK first. Okay, click on OK. So after clicking on OK, you go to analyze advanced Sapphire options. So in the advanced Sapphire options, you have just select multi-threaded solver. Just select multi-threaded solver, and then click on OK. Okay, and then again go to analyze and set load cases to run. So you can see, and let's click on run now. So before clicking on run now, you know that while we'll run the analysis, it will take a lot of time depending upon your structure. The bigger the structure, the more time it will take. Approximately at least half an hour it can take depending upon your system. So click on run now. So the analysis is done now. So once the analysis is done, you can just click on the start animation, right? You can see it's the start animation, and you can just click on next here. I'll just close this for better view. Okay, next you can just do like this. So as long as it remains within the green, it is within the limit. When it goes in the teal color, then it is out of the bearable limit. As you can see the hinges are still within the limit. And now you can see now in this frame, from this frame onwards, it is teal color. So it means this has gone beyond our allowable limit. Okay, so you can see like this. Now it has become in the last just a frame, it has become, that is 29, step number 29, it has become your red, means it is failed. So you can see all the hinges have failed in step 29. So there are 29 steps in total. Okay, so you can also use this shortcut display and display this deformed shape, and PQX or PQY, suppose let's go PQY, step number, you can just see step number, let's give 20, and click on apply. You can see these are the step number, and you can just change from this also. 3, click on apply. Just go to PQX here, step number 2, click on apply the PQX, and here just click on apply like this. So you can see these steps also. 5, click on apply. So like this also you can see it here, all the results of PQX and PQY. Step number 1, apply, so all are green, and step number 3, let's go, some are red and some are teal color. So you can see this like this. So let's see the story response plot and display the story response plots. You can see the maximum displacement, maximum story displacement in mm, and you can see this, the maximum displacement is more than 13.5, and you can see this is the story response 1, and I can also see the maximum story drifts at 7.2 around, and this story stiffness. So all this we can see here, and let's do this load combination PQX, and let's see the maximum story displacement here due to PQS. You can see this, it's around 9 mm. So this is the maximum story displacement here. So this you can do, and if you want, let's display the plot function. So the plot function you can see here, and load case PQX and PQY, these are the functions which you can see. Let's see the PQX here, and base effects you can see here, and also step you can see here. So this you can see from the graph, and details will always find in the ASCE code. I'll discuss about that later, but this is the process in which it is done. And again you can go to display and show tables. Okay, just before that, display hinge results. Let's see. Okay, you can see these are the, let's close this and just maximize this to show these are the hinge results. So these are hinge response for PQX and obviously M3, and this is, let's see, for PQY. Okay, just zoom in, and object type, frame type, beam. Okay, just reset this, display hinge results. Now you can see this is for column and this is for beam. So like this you can see for the hinge results. Now I'll go to just close this and display, and will display show tables and design, analysis and response spectrum functions. You can see this response spectrum function, time history functions not done, load combination results and shell results. Okay, you will see the results, frame results and beam forces, column forces, reactions. Okay, all this you can see, shell results, cell forces. So all this also you can see in the response spectrum function. You can see it here in the acceleration. So you can see all the results, and if you want to see the shear force and bending moment diagram also, let's check it out. First of all, let's make it undeformed shape. So undeformed shape first, and after undeformed shape you want the display, not this one, show the shear force and bending moment diagram. So we'll go to display here and display force stress diagrams, and let's go to this, let's go for check for this PQX, and let's just suppose step number 6 and shear force diagram, and click on apply. You can see, and shear force 2 also, just click on apply, and you can see the shear force diagram here for the shear force 2, and moment also you can see moment here, and for the dead load also moment and shear force. Okay, shear 2, that is the shear force diagram, and moment also you can see. And for this PQY also, just give the step number, and you can see the shear force, bending moment let's see the values as well. Now show the values, and or you can see the shear force also. So shear force and bending moment both you can see in here for all the pushover analysis. So, and just you need to define the step, and you can see the values like this, you can observe. So that's all in the pushover analysis here. And if you like this video, just make sure you drop a like, and if you want to see anything or if you have any doubt, make sure you leave a comment. Thank you. Bye bye.